All right, now we are on number 11. Find the length of the missing leg below. All right, so we're supposed to use the Pythagorean theorem to figure this out. So the theorem says if you do the square of the smaller legs, so if you do x squared plus 13 squared, that should equal the hypotenuse squared. And that hypotenuse is always the one that's across from your right angle. Right? We'll simplify these. X squared, that'll be 169. 15 squared is 225. So instead of adding them and then taking the square root, we're going to subtract them and then take the square root. So I'm going to minus 169. What is that? 225 minus 169 is 56. And then you would take the square root. So x is equal to the square root of 56. If you look down here, none of those match exactly. What you would have to do, all right, there's two ways to do it. You could either make this into a decimal and then compare that to the decimal versions over here. The other way is to simplify this radical. You take out a 4, I believe. You could rewrite that 56 as a 4 and a 14. That's the biggest perfect square that goes into 56. And then the square root of 4 turns into a 2. So your answer is going to be 2 root 14. Okay. But if you were to look at those on your calculator, well, can't get that to work. That's okay. 2 root 14 as a decimal is 7.48. And if you check on the square root of 56, it's also equal to 7.48. Okay. All right, number 12. Where you at? All right, these two triangles are similar, and we need to figure out the segment x. All right, what I'm going to do first is I'm going to redraw this, but rotate it, I guess. So they're supposed to be, it's easier when they're oriented the same. Okay, so the 10 is that, this 10 right here is going to be right there. And then the x is going to be the longer of these two legs right here. All right, the longer of those two legs. So that's x. All right, and then we need to write a proportion to compare the two. We could do 10 corresponds to 12. All right, these two correspond to each other. 10 corresponds to 12. And then the x corresponds to the 10. And then we could cross multiply to solve it. 10 times 10 is 100. This is 12x. And then you'll divide by 12. 100 divided by 12 is 8.33. All right, what's the length of the hypotenuse for a right triangle whose legs are 9 and 12? All right, so they give us the legs, and we want to figure out the hypotenuse. So you could draw the triangle if it helps. 9, 12. And then we're figuring out that one right there. So your setup would be 9 squared plus 12 squared equals x squared. That's how you could solve it the old-fashioned way with the Pythagorean theorem. The trick here that you should always be on the lookout for is that it is related to a 3, 4, 5 triangle. Okay? Because the 9 and the 12 are just a scaled up version of 3 and 4, okay? You can just take 3 times 3 and get 9, and you can do 4 times 3 to get 12. That means if you want to figure out your hypotenuse, you could do 5 times 3. Okay? If you multiply that, you'll get 15. And candy machine, there are gumballs and sour candies at a ratio of 2 to 5. What's the percentage of the machine that's made up of gumballs? Okay, so for the percentage, you want to compare the number of gumballs to the total. That's how you figure out the percentage. All right, so the gumballs is a 2, and the total would be a 7. And then you just divide those two numbers, and that's going to give you 0.2857, which is going to be about 29% if you round up. Okay. Oh, the last one's easy. The last one's just a proportion. So you could cross multiply to solve it. You get 54 is equal to 2x. This one you can solve using just a little multiplication trick. If you look here, 2 times 3 will give you 6. So 9 times 3 will give you your answer. Okay? 9 times 3 is 27.